Hi guys, in this video I'm going to be going over how to evaluate these three trig functions at angles that are related to theta. Let's get started. Let's start by figuring out the cosine of pi plus theta. The first thing is to recognize that pi is a half turn around the circle. Pi radians is a half turn. Originally, we've already rotated by theta, so we need to rotate an additional half turn to evaluate this expression. I'm taking now the terminal side and rotating it through 180 degrees, or pi radians. Now the total amount of rotation is theta plus pi, which is what we want. I'm going to go ahead and figure out this reference triangle, which is just rotated around 3 to 3, 4 to 4, 5 to 5. That helps me now to figure out the coordinates of this point that's rotated around. I'm right 4 and down 3. The coordinates are 4 and negative 3. The cosine is the ratio of x to r. So we have the ratio of 4 to 5. Next, let's figure out the sine of theta plus 2 pi. Here we recognize that 2 pi represents a full turn around the circle. So we'll start by rotating theta and then go past it by another full turn. Now the total amount of rotation is theta plus 2 pi, which is what we want. The sine of that angle is the ratio of y to r. So here we have the ratio of 3 to 5. Next, let's find the tangent of pi minus theta. It will help us to find pi minus theta in our diagram. Let's take a look at the angle that's adjacent to theta. Now, if you were working in degrees, you'd know exactly what to do here. The angle that's adjacent to 160 must be 20 because it forms a straight line, and that's easy to do by subtracting from 180. Well, here we're in a similar situation. We'll just work in radians. The angle that's adjacent to theta must be pi minus theta. So there's pi minus theta in our diagram. Now that we've located pi minus theta in our diagram, let's evaluate the tangent of that angle. In order to evaluate the tangent, we need to put that angle into standard position. Right now, one of its sides is pointing to the left. We need it to point to the right. So ask yourself, how can I make the angle point to the right? Well, of course, you can do that by reflecting over the y-axis. If we reflect over the y-axis, the bottom side now points to the right. The oblique side now points in this direction. And we can reflect the entire figure, including the triangle. The vertical side is 3, the horizontal 4, and the oblique side is 5. When we do that reflection, the obtuse angle theta ends up over here, and the acute angle pi minus theta ends up right here in standard position, just where we wanted it. Now we can figure out the tangent of that angle by finding the ratio of y to x. But first we need to get the coordinates of this point. It's over 4 and up 3, so 4, 3. And the y to x ratio is 3 to 4. This completes the walkthrough of the sample problem. Good luck on your exit ticket, and we'll see you soon.